Hello everyone. Today I would like to talk about the entropy series, the second set of problem solving. So here I'm going to explain how we can determine the entropy increasing or entropy decreasing in a given chemical process or a reaction. Let's see questions one by one. Which of the following phase transition results in increase in entropy? There are three phase transitions given. First one is solid to liquid. So we call solid to liquid melting, liquid to gas, that is evaporation, or solid to gas, this is sublimation. The solid to gas transition we call sublimation, that is involved with increase in entropy among these three phase changes, because the substance going from highly ordered solid phase to the highly disordered gaseous phase in the sublimation phase transition. The entropy is highest in the gas phase, the entropy is lowest in the solid phase. Entropy is intermediate to the solid and the gas phase is the liquid. Question number 2. The given equal amounts of oxygen gas and the ozone at 25 degrees Celsius, which substance has the higher standard entropy? Ozone. Ozone is O3. It has higher standard entropy than oxygen O2. The reason is ozone is more complex molecular structure. There are 3 oxygen atoms that leading to more microstates. Question 3. Between methane CH4 and ethane C2H6, which has the higher standard entropy at 25 degrees Celsius, and why? If we compare CH4 and C2H6 structure, ethane is very complex structure, more carbon and hydrogen atoms compared to methane. Ethane has a higher standard entropy because of the higher number of atoms and the molecular size, more possible configurations that leading to greater number of microstates. Consider the reaction 2 moles of nitrogen monoxide react with oxygen to produce 2 moles of nitrogen dioxide. Now this chemical reaction from reactant side to the product side, entropy increasing or entropy decreasing? All 3 species given in the reaction are in the gas phase. Then we need to focus on number of gaseous molecules in the reactant side and the product side. The number of gas species, 2 moles of NO and 1 mole of O2, total 3 moles, 3 gas molecules in the reactant side. But the product side, only 2 molecules of gases. Number of molecules of gases decreasing from reactant to products. Therefore, the entropy decreasing. Between liquid water and the water vapor at 100 degrees Celsius, which has the higher entropy? As we discussed in the previous slides, solid has the lowest entropy and the second largest is the liquid phase, and larger entropy or larger disorder, more disordered phase is gaseous phase. Here water vapor means gaseous phase water. If we compare liquid and the gas phase water, water vapor has high entropy than the liquid phase. The reason is gaseous state allows for more freedom of movement than the liquid phase. How does the entropy of the given substance change with temperature? If we increase the temperature from 0 degrees Celsius to 100 degrees Celsius. With increasing temperature, entropy increases. The reason is molecules gain more kinetic energy. After we increase the temperature, they absorb heat energy and increase the molecular motions. Increasing the molecular motions possible to increase more microstates. That leads to high entropy. Consider the mixture of 2 gases, helium and the neon. So helium and neon are inert gases. So another name is noble gases. They are located at group HA or the group 18, the last column of the periodic table. Will the entropy of the mixture be higher or lower than the entropy of the pure gases combined? The entropy of the mixture will be higher than the sum of the entropies of the pure gases. The reason is mixing increases the disorder of the system. that leads to more possible configurations or more microstates than the individual gases. Next slide, let's move on to the standard entropies calculation for chemical reactions. Let's talk about the calculate standard entropy change for this given reaction. Here I plan to calculate three reaction standard entropy values. First reaction is PCl3 combined with Cl2 to produce PCl5. You can see in table standard entropy values are given. PCl3 311.7, Cl2 223.0 and PCl5 352.7. These standard entropies values you can find it from in any textbook's appendix section or from the internet. And the values given in the units of joules per mole per Kelvin. Now the equation is delta S naught Rxn, that is standard entropy change for this reaction. Rxn is reaction is equal sum of all the standard entropy values of the products minus sum of standard entropy values of the reactants. If we apply the values, PCl5, 1 mole of PCl5. PCl5 value is 352.7 minus, there are two reactants, PCl3 311.7 plus Cl2 is 223. After you solve this, you can see the values negative 182.0 joules per mole per Kelvin. Now let's see why the entropy values for this reaction is negative. If you go to the reaction and analyze, PCl3 and Cl2 are gas phase reactants, two molecules. In the product side, only one molecule of the gas molecule. So number of gaseous species decreasing from left to right. Entropy decreases. That indicates this negative sign. Second reaction, methane combustion reaction. In the methane combustion reaction, carbon dioxide and 2 moles of water are the products. Values given in the table in joules per mole per Kelvin. Let's apply the same equation, the product's standard entropy values minus the reactant standard entropy values. Here N and M are smaller coefficients, that is the coefficients or the numbers we use to balance the equation. First product side, carbon dioxide 213.6, only one carbon dioxide molecule, so 1 times 213.6 plus 2 molecules of H2O. So 2 times H2O value is 69.9. Those are the products. Minus then reactants. 1 times CH4 value is 186.2 plus 2 molecules of oxygens. 2 times 205.0. After solve this, the value is negative 242.8 joules per mole per Kelvin. Now why this is negative here? If you go to the reaction, CH4 gas phase and oxygen also in gas phase. There are 3 gas phase molecules in the reactant side. But product side, only one gas species. Carbon dioxide is only the gas phase molecule. The other two are liquid phase. So here entropy decreasing from reactant to product side, from left to right. The reason is number of gas molecules decreasing from left to right, and another reason is more ordered liquid phase has formed in the product side. Next reaction, magnesium carbonate decomposition. Magnesium carbonate decomposed into magnesium oxide and carbon dioxide. Now let's calculate delta S naught Rxn for this reaction. The same way we can apply the equation delta S naught products minus S naught reactant values. The product values are MgO value 26.78 times 1 plus carbon dioxide value 1 times 213.6 minus reactants. Only one reactant, that is magnesium carbonate 65.69 is the standard entropy value. Then the reaction standard entropy change is positive 174.7 joules per mole per Kelvin. Why this is positive value? Positive value indicating increase in entropy. In the reaction solid phase, is in the reactant side, that is more organized. Particles are closely packed and very organized. High organized phase entropy is less, entropy low. In the product side, again the solid phase, magnesium oxide, but carbon dioxide is a gas phase. More disordered carbon dioxide formed in the product side. So ordered phase become more disordered phase in the product side, entropy increasing. Number of gas molecules increased from left to right, that indicate by this positive sign, entropy increased. Next, let's see how we can describe the sign of the entropy change for this given reactions. First reaction is nitrogen and oxygen combine to form nitrogen monoxide. The reaction is balanced. One molecule of N2 or 1 mole of N2 combined with 1 mole of O2 to produce 2 moles of NO. Is this reaction entropy increasing from left to right or entropy decreasing from left to right? There are two gas molecules on the reactant side and two gas molecules on the product side. Therefore, the number of gas molecules in reactant and product side equal, same. No significant change in entropy in this reaction. Second reaction, ammonium chloride is a solid. It is decomposed into ammonia gas and HCl gas. So here entropy increasing or decreasing. The solid in the reactant side, solid phase means more organized. Particles are closely packed and very organized. Therefore, less disorder and lower entropy. In the product side, gas phase, there are two molecules in the gas phase. Gas phase means molecules are higher in motion, they are very disorganized, higher entropy. Lower entropy reactants become larger entropy gas phase, entropy increasing from left to right. Next reaction. Uranium is a solid phase. Uranium combined with gas phase fluorine and then produce uranium hexafluoride in the solid phase. Now is this reaction entropy increasing or decreasing? You can see solids in both sides. The uranium is a solid and a uranium hexafluoride is a solid. However, the reactant side has three fluorine gas molecules, more disordered phase, high entropy phase. It disappears in the product side. So entropy is decreasing in this reaction from left to right. The reason is more ordered solid phase is formed in the product side and the number of gaseous species decreasing. So it becomes more ordered products from the disordered reactants. Entropy decreasing. I hope now you will understand how we can predict the entropy increasing or decreasing in the given process or chemical reaction, and how we can calculate the standard entropy change for any kind of chemical reaction using their standard entropy values. Thank you all for watching. If you find this helpful, subscribe to the channel for more learning.